Hello everyone, I welcome you all to my online classes. This is Om Maths Corner. Today we shall discuss revision plan. Topic is continuity and differentiability. Here we shall discuss most important questions on the basis of previous years CBSE board examinations. So let us see what is there in the chapter continuity and differentiability, most important questions. Here we shall discuss most important questions. I have selected the questions from the previous board examinations question papers. The first question discuss the continuity of f of x is equal to this. Second question, third question is this. Fourth question, 5, 6, 7, 8, 9. So I have collected all these questions and written on the notebook, and today we are going to discuss all these questions one by one so that the children may get the benefit. So let us proceed now. The very first question is discuss the continuity of f of x is equal to square root of 1 plus 3x minus square root 1 minus 3x whole divide sine of x whenever x is not equal to 0. This is 3 when x is equal to 0. So because here this is given x is not equal to 0, it means we are just taking limit x approaches to 0. Limit x approaches to 0 of the function f of x. And the value of this f of x here is, this is as limit x approaches to 0 square root of 1 plus 3x minus square root of 1 minus 3x whole divide sine of x. There is no need to take left-handed limit or right-handed limit whenever x is not equal to 0 is given here. Okay, so first of all what we do, we try to substitute x equal to 0 here in the function directly. Let us see what happens. 1 plus 3 into x, 3 into 0, this becomes 1. 1 minus 1 is 0. Sine 0 is also 0. So we write here 0 by 0 form. And 0 by 0 form, it means this form is called indeterminate form. Indeterminate form. What is the meaning of indeterminate form? The meaning of indeterminate form is we cannot put x equal to 0 directly. We cannot put x is equal to 0 directly. Some other method we have to think of. Some other method here we are going to see which method we should introduce here. Now one more thing in the denominator, what we see in the denominator, this is a sine of x. So what we should do here, sine of x mean we know the standard result. What is the standard result? Result is limit x approaches to 0 sine of x divide x, the value is always equal to 1. This is the standard result which is on the tips of each and every student. Now, because this square root symbol, rationalization process is always better. What is that? First of all, write the whole function as it is here, this way. Whole function is written as it is, there is no change. Now rationalization process mean we multiply this numerator, whole term will be written square root of this 1 plus 3x. Just we shall change the sign. If this is minus, then put here plus. If this is plus, then put here minus. Now we are taking plus sign, 1 minus 3x. In the denominator also we write the same number, that is 1 plus 3x plus 1 minus 3x. By doing this way, what happens? Suppose this is a, this is b. A minus b into a plus b, which is equal to a square minus b square. So we also write here limit x approaches to 0. A is 1 plus 3x, its whole square, minus b square. B is square root of 1 minus 3x, its whole square. And in the denominator, this is first of all sin x. Next, this whole bracket is there, square root of 1 plus 3x plus square root of 1 minus 3x. Now further, what happens? Limit x approaches to 0. Square root and squares cancelled. What is there now? 1 plus 3x minus sign. Square root square cancelled. 1 minus 3x. Right? So denominator, no change. Sin x into square root of 1 plus 3x plus square root of 1 minus 3x. Next here we have limit x approaches to 0, 1 plus 1 minus cancelled, plus 3x, minus and minus plus 3x. 3x plus 3x is 6x. Denominator is sin of x into square root of 1 plus 3x plus square root of 1 minus 3x. This way. Now using the same standard result. What was the standard result? Limit x approaches to 0, sin x upon x is equal to 1. So this value is 1. And rest terms, what we do? We write 6 as it is, square root of 1 plus 3x. Now we can put directly x equal to 0 after applying this some other method. So this becomes 1 plus 0, 1 plus 0, that is 2. 1 plus 1, 2. So what is the limit? 6 upon 2 is 3. Now next question. Question number 2. Determine the constant so that the given function f of x is equal to kx plus 1 when x is less than or equal to 4, 3x minus 5 when x is greater than 0 is continuous at x is equal to 5. Here first of all we write the function as it is. This way, kx plus 1 when x is less than 5, this is equal to again kx plus 1 when x is equal to 5, 3x minus 5 when x is greater than 0. So first of all what we see here x is less than 5. So from here we write limit x approaches to 5, negative sign, mean left handed limit of the function, and the function value here is kx plus 1, kx plus 1, right? Similarly, next time from here we see x greater than 5. So from here we conclude limit x approaches to 5 plus symbol, that is right handed limit. So here the name of the function is 3x minus 5. Okay, and from here x equal to 5, this gives us functional value f of 5, which is equal to we directly put in place of x 5, k into 5 plus 1. Okay, now the function is continuous at x is equal to 5. F of x is continuous at x is equal to 5. This implies this left-handed limit x approaches to 5, left-handed limit, we just write here f of x of the function should be equal to the functional value f of 5, should be equal to limit x approaches to 5, right-handed limit of the function. Okay, first of all we evaluate here what is left-handed limit. Here we can put directly x is equal to 5, so this becomes 5k plus 1, and this is also 5k plus 1. Here put x is equal to 5, this 3 into 5 15, 15 minus 5 is 10. Okay, now these values will be substituted here. That is left-handed limit is 5k plus 1 equal to functional value is also 5k plus 1, and right-handed limit value is 10. Because these two members are same, so just we are picking up these last two members. From here we can say, we can conclude 5k plus 1 is equal to 10. That is 5k is equal to 9. So the value of k becomes 9 upon 5. So what was the question? Determine the constant. Constant was k and the value of k is 9 upon 5. So this was question number 2. Now next question. Now question number 3. Determine the constants a and b so that the given function f of x is continuous everywhere. This is the function f of x is equal to 5 when x is less than or equal to 2, ax plus b when x is greater than 2, less than 10. This is 21 when x is greater than or equal to 10. So here we see the equality sign at two places, at x equal to 2, at x equal to 10. So likely we shall discuss the continuity at x is equal to 2 and at x equal to 5. So first of all, x is less than 2. X is less than 2, it means left-handed limit x approaches to 2, left-handed limit of the function. The value of the function here is 5, right? And put x equal to 5, there is no x, so this will remain as it is, 5. And from here x is greater than 2. From here what we find, the value of the function is ax plus b. So we write here right-handed limit x approaches to 2. This plus symbol means right-handed limit. We write this function of ax plus b. Okay, so we now put x is equal to 2 in this function. This becomes a into 2, 2a plus b, right? Moreover, equality sign, what is that? So from this we say f of 2, functional value f of 2 is 5, right? Now this function is continuous at x is equal to 2. It means left-handed limit should be equal to right-handed limit. We write this way, limit x approaches to 2, left-handed limit means this negative symbol, equal to right-handed limit means limit x approaches to 2 plus symbol of the function should be equal to the functional value. Okay, so what is the conclusion? Conclusion is, what is left-handed limit? This is 5. What is right-handed limit? This is 2a plus b. And what is f of 2? This is also 5. Just only one equation we get here. This is 2a plus b is equal to 5. Right? Now we solve second part. Limit continuity at x is equal to 10. First of all, x is less than 10. X is less than 10. From here, we write limit x approaches to 10, left-handed limit, less than 10. And the function value is ax plus b. So we write limit x approaches to 10, left-handed limit. The function is, just here we are writing ax plus b. Directly we can put x is equal to 10 now. This becomes 10a plus b. Second time we see x greater than 10. So x greater than 10 gives us right-handed limit. Limit x approaches to 0, 10 plus symbol means right-handed limit. And the functional value here will be 21. Okay, the answer is 21. Moreover, what is the functional value at x is equal to 10? Equal to 10, x equal to 10, functional value is 21. Okay, question is determine constants a and b so that function is continuous everywhere. Mean to say the function is also continuous at x is equal to 10. So like this we write the condition. What is the condition? Limit x approaches to 10, left-handed limit of the function should be equal to limit x approaches to 10, right-handed limit of the function. These two are equal to functional value at x is equal to 10. So what is left-handed limit? This is 10a plus b, this one. And what is right-handed limit? This is 21. And what is functional value? This is also 21. From these two, we get the relation 10a plus b is equal to 21. So two equations are available now. This is first and this is second. We solve these two equations and find the values a and b. Simply we write second equation here and we subtract now. On subtracting, the symbols signs changes, minus minus. 2 minus 10 is minus 8a. b cancelled. 5 minus 21 which is equal to minus 16. So from here conclusion is a is equal to 2. We put this value of a here. 10 into 2, 20 plus b is equal to 21, which gives us the value of b is 1. So what was the question? Determine constants a and b. A is 2, b is 1 when the whole function is continuous everywhere. Now next question. Question number 4. Show that f of x is equal to modulus of x minus 3 for every x belonging to the set of all real numbers is continuous but not differentiable at x is equal to 3. Two things we have to see here. One is continuity, second is differentiability. First of all, we take continuity case. We write the function modulus of x minus 3. F of x is equal to modulus of x minus 3. This we can write like this. This is plus x minus 3 whenever x minus 3 is greater than or equal to 0. And this is minus x minus 3 when x minus 3 is less than 0. Right? From here we conclude this is x minus 3 when x is greater than or equal to 3, and this is minus x plus 3 when x is less than 3. Right? So this way we are writing function this value here. This way Now first of all we check the continuity. x is less than x is greater than 3. From here we'll find right-handed limit. Limit x approaches to 3, this plus symbol of the function. Functional value function is x minus 3. So we write x minus 3. Now we put x equal to 3. The value is 3 minus 3 is 0. Second time we check where is x minus x is less than 3. From here we write left-handed limit. Limit x approaches to 3, left-handed limit of the function value is minus x plus 3, right? So we are here substituting x is equal to 3 again. Minus 3 plus 3, this is also equal to 0. Moreover, what is a functional value? We put directly x equal to 3 here. So this gives 3 minus 3. This is also equal to 0. So from here what we conclude, limit x approaches to 3, left-handed limit of the function is equal to functional value at x is equal to 3. This is equal to right-handed limit x approaches to 3 of the function, right? So if we are in the position to write this statement, because 0 equal to 0 equal to 0, so these three are equal, it means this implies the function is continuous at x is equal to 3. So we write f of x is continuous at x is equal to 3. Now we shall discuss about differentiability at x is equal to 3. We know the condition that a function is said to be differentiable if left-handed derivative is equal to right-handed derivative. F of x is said to be differentiable at x is equal to 3 if left-handed derivative mean limit x approaches to 3, this minus sign left-handed derivative, f of x minus f of 3 upon x minus 3. Right-handed derivative we just write plus sign, the same value is written here, f of x minus 3 upon x minus 3, right? Now if we directly put left-handed limit of the function at x is equal to 3, so this is 0, f of 3 is also 0, 3 minus 3 0, this becomes 0 upon 0 form, indeterminate form. It means direct substitution is not allowed. So other method we have to think of. What should be the other method? We just put this is written here, limit x approaches to 3 f of x. What we do, we put x minus 3 is equal to h. So x is equal to 3 plus h. Okay, in case of left-handed limit we put 3 minus h, and in place of right-handed limit we put x is equal to 3 plus h. So here this becomes limit h approaches to 0, left-handed limit f of x, this becomes f of 3 minus h minus f of 3 divide x is 3 minus h minus 3, which is equal to limit h approaches to 0, right-handed limit symbol, f of 3 plus h minus f of 3 divide. This implies we write here limit h approaches to 0, left-handed limit functional value, this is the left-handed limit, minus x plus 3. So in place of minus x plus 3 we put x is equal to 3 minus h. So this becomes minus 3 minus h, okay, in place of x plus 3. Next is minus f of 3. minus f of 3 value is 0. Divide 3 minus 3 cancelled, only minus h is left. Likewise, right-handed derivative limit h approaches to 0. F of 3 plus h. 3 plus h mean x is greater than 3. X minus 3 is the value. So we put x is equal to 3 plus h. 3 plus h. Okay. Minus 3. Next is this minus f of 3. F of 3 is 0. Divide 3 cancelled, only h is left. Right. So this implies now, what implies, we have minus 3 plus 3 cancelled plus h upon minus h, this is minus 1, is equal to, here 3 cancelled plus h upon h, this is equal to 1. So what we say, minus 1 is equal to 1, this is not true. So our conclusion is f of x is not differentiable at x is equal to 3, because left-handed derivative at 3 is not equal to right-handed derivative at x is equal to 3. This was question number 4. Now next question. I want to say here, the function is continuous and not differentiable. This question is very important to the examination point of view. So let us proceed now towards next question, question number 5. Question number 5. If x into square root of 1 plus y into square root 1 plus x is equal to 0 for x greater than minus 1 less than plus 1, prove that dy upon dx is equal to minus 1 upon 1 plus x whole square. So here what is the function? Let us write this, the whole function. This is the given function. So what we do, we write x square root of 1 plus y. We take this whole term to the right hand side, becomes minus y into square root of 1 plus x. Right. Now we square on both sides, squaring on both sides. So what happens, this becomes x square into 1 plus y. Right hand side becomes minus square mean plus, y square into 1 plus x, square root cancelled. Right. So now multiplying, we have x square plus x square into y, and this will also y square plus x into y square. Right. Now we take this y square to left hand side, that is x square minus y square. This is equal to, what is equal to, x into y square. This term will go here, minus x square into y. Now what we do, a square minus b square factorization is x minus y into x plus y. Similarly, right hand side we take x into y common, so we are left with y minus x. Right. Moreover, we can write this as this way, by taking minus sign outside. So this becomes x minus y in place of y minus x. Now what happens by doing this, x minus y is common, so these two terms are cancelled. So what we are left with now, we are left with, left hand side is x plus y and right hand side is minus xy. Right. Now again we solve this, becomes x plus xy plus y is equal to 0. Right. Now take y common from first, second and third term. We have x plus, taking y common we have x plus 1 is equal to 0. Now what we do, we write y into x plus 1. This term is written here, x will go to right hand side, becomes minus x. So what we write, y is equal to minus x divide x plus 1. Okay, now differentiating with respect to x. Okay, we know the rule. What is the rule? Quotient rule of derivative. What is the quotient rule? U upon v derivative, v into u dash minus u into v dash upon v square. So here u is minus x, v is x plus 1. So we write dy upon dx is equal to, first of all, denominator v, that is x plus 1. Next, u dash, derivative of minus x is minus 1, minus u mean minus x, into derivative of denominator, x plus 1 derivative is 1, and the square of denominator mean x plus 1 whole square. Okay, so what is this? This is right hand side. On solving, what we find, we see here dy dx, this becomes minus x minus 1 plus x, divide x plus 1 whole square, minus 1 plus this is minus plus x plus x cancelled, so we have minus 1 upon x plus 1 whole square. So this was what we wanted to prove. Now next question. Now question number 6. Differentiate tangent inverse square root of 1 plus sin x plus square root 1 minus sin x. Divide square root 1 plus sin x minus square root 1 minus sin x with respect to x. One trick we are going to follow here. What is that? We know that sine square theta plus cos square theta is equal to 1, right? So what we can say, 1 is equal to sine square, in place of theta we are writing x by 2 plus cos square of x by 2, first thing, in place of 1. Next rule, we know. What is the rule? Sine 2 theta is equal to 2 sine theta into cos theta. So from here we can say, what we can say, in place of 2 theta we put x, sine of x. So this becomes 2 sine x by 2 into cos x by 2. Okay, by writing this way, that is taking 1 is equal to sine square x by 2 plus cos square x by 2, and sin x equal to 2 sine x by 2 into cos x by 2. This term, square root of 1 plus sine x, this becomes square root of 1 mean this whole term, sine square of x by 2 plus cos square of x by 2. Sin x mean plus 2 sine x by 2 into cos x by 2, right? So this becomes equal to square root of sine x by 2 plus cos x by 2, its whole square. Now this square root and square is cancelled, so we are left with only sine of x by 2 plus cos x by 2. Similarly, when we shall solve this square root 1 minus sine x, we put here minus sign, so this will become sine of x by 2 minus cos of x by 2 whole square, that is sine of x by 2 minus cos of x by 2. Now we substitute these values here. Okay, what happens? First of all, consider, let f of x is equal to the whole function. Now we substitute the values. Tangent inverse, what is the square root of 1 plus sin x? The value is sine of x by 2 plus cos x by 2. As this is discussed, what is the square root of 1 minus sin x? Just only we put minus sign here, sin x by 2 minus cos x by 2, and denominator is also like this, Sin x by 2 plus cos x by 2 minus sin of x by 2 minus cos of x by 2. Now what happens? This is equal to tangent inverse of plus cos x by 2 minus cos x by 2 cancelled. Sin x by 2 plus sin x by 2 is 2 times sin of x by 2. Similarly, in the denominator, sin is cancelled. 2 cos x by 2. 2 cos x by 2. Right? So here this is equal to tangent inverse of 2 to cancel. Sin upon cos is tangent of x by 2. Again tangent inverse tangent cancelled, we are left with only x upon 2. Now very simple, if f of x is equal to x by 2, so what is f dash x? The derivative of x is 1 upon 2. X by 2 derivative is 1 upon 2. That's all. Now next question. Question number 7. Differentiate tangent inverse x upon square root 1 minus x square with respect to sine inverse 2x square root 1 minus x square. So here what we do, suppose this is u and suppose this is v. Now differentiate u with respect to v. So what is to find? Find du upon dv. Right? So here u is tan inverse x upon square root 1 minus x square. Simply if we put x is equal to sine of x, then what happens? Not sine x, sine theta. Sine theta divide square root of 1 minus sine square theta. So this gives us tangent inverse sine theta. 1 minus sine square theta is cos square theta, cos square, square root cancelled, that is tangent theta. So tangent inverse tangent cancelled, only theta we are left with. What we have substituted? We have substituted x is equal to sine theta. So from here we can say theta is equal to sine inverse x. So we have du dx, derivative of u with respect to x, sine inverse x formula directly. What is the formula? 1 upon square root of 1 minus x square, its derivative. Similarly we take v. This was u. Now what is v? V is equal to sine inverse of 2x into square root 1 minus x square. Here what we do, in place of x we put sine phi. So this becomes, this is equal to sine inverse 2 sine theta into 1 minus sine square theta, that is cos square theta, square root cancelled, cos theta. 2 sin theta cos theta, which is equal to, sorry, in place of theta, because we are already taking theta, we can take here phi symbol. In place of theta we are taking phi, right? Otherwise there is no problem, we could also take this also. So what happens, this is sine inverse 2 sin phi cos phi, which is equal to sine of 2 phi. Sine inverse sine cancelled, 2 phi. Okay, now what is the thing? What was phi? Phi was equal to x is equal to sine phi. X is equal to sine phi. So from here we have phi is equal to sine inverse x. Sine inverse x. So what we write here now, dv upon dx is equal to 2. Sine inverse x derivative is again 1 upon square root of 1 minus x square. Right? This way the derivative of v is available, derivative of u is also available. Now we put this value here, du upon dv, we can write this as du upon dx whole divide dv upon dx, that is equal to du upon dx, value is 1 upon square root of 1 minus x square, and this is also dv upon dx is 2 upon square root of 1 minus x square. Denominator is the same, cancelled, so only we are left with 1 upon 2. So this is the required derivative, differentiate u with respect to v, so this is the derivative 1 upon 2. Now next question, question number 8, if x raised to power y plus y raised to power x is equal to 1, then find dy upon dx. So here we have the form variable raised to power variable, variable raised to power variable, x raised to power y or y raised to power x. Suppose this is the function f of x, then how to find the derivative f dash x? F dash x is, or to say here we take log on both sides, taking log on both sides, this becomes log of f of x is equal to log variable raised to power variable. Suppose this is variable 1, this is variable 2, so we write log of variable 1 power variable 2. Now log m power n, we can write this as variable 2 log variable 1. Okay, now differentiating both sides, log f of x derivative 1 upon f of x into f dash x is equal to right hand side derivative, that is derivative of variable 2 into log variable 1. Now this f of x will go here, so we write f dash x is equal to f of x into derivative of variable 2 into log of variable 1. We follow this process and here we apply the same, x raised to power y plus y raised to power x is equal to 1. Differentiating with respect to x, we get according to this rule, first of all we write x raised to power y into derivative of, this becomes y into log of x plus y raised to power x into derivative of dy upon dx of x log y, x log y, right hand side derivative constant derivative is 0, so here this is equal to x raised to power y into u into v, first function log x derivative is 1 upon x plus log of x into y derivative is dy upon dx. Second part, y raised to power x, first part, first function, second function, first function as it is, log y derivative is 1 upon y into dy upon dx plus log of y into x derivative is 1, right hand side is 0. Now we solve this, x raised to power y in the denominator x, so we write y minus 1 power into y plus x raised to power y into log of y, log of x into dy upon dx plus this is y raised to power x, this y will reduce the power into x into dy upon dx plus y raised to power x into log of y is equal to 0. Now what we do, we collect dy upon dx terms at left hand side, these two terms are written here and rest terms they are written to right hand side, that is they will go here with minus sign. Okay, now taking dy upon dx common this way and writing right hand side taking minus common, right, we have written this. Now what we do, this whole term will be divided here at right hand side this way. So find dy upon dx. So this is the required result. Dy upon dx minus x raised to power y minus 1 y plus y raised to power x into log of y. Divide this whole term. Okay. So this was question number 8. Now next question. Once again I want to mention here this question number 8. This question is very important question to the examination point of view. So now proceeding towards question number 9. Question number 9. If y is equal to tan inverse x whole square, show that x square plus 1 whole square y2. y2 mean double derivative d square y dx square plus 2x into x square plus 1 y1. y1 mean dy dx first order derivative is equal to 2. Okay, so here first of all this is the given function y is equal to tan inverse x whole square. We differentiate this with respect to x. Suppose this is equation number 1. We differentiate with respect to x. So we have dy dx is equal to power, the rule x raised to power n. X raised to power n derivative is equal to n into x power n minus 1. This rule we apply here. Okay, this becomes 2 power tangent inverse of x whole raised to power 2 minus 1. But because this was not x, so we differentiate tan inverse x once again. Chain rule, this is called chain rule. Tan inverse x, its derivative once again. So here dy upon dx value we are taking y1 is equal to 2 tan inverse x whole power 2 minus 1 is 1. Tan inverse x derivative is 1 upon 1 plus x square, right? So denominator we multiply this here, becomes 1 plus x square into y1 is equal to 2 times tangent inverse of x, right? Now once again what we do, differentiate with respect to x. Again differentiate with respect to x. So u into v, first function u as it is 1 plus x square into derivative of y1. Derivative of dy upon dx is d square y upon dx square, which is y2, plus for second function as it is y1. Derivative of 1 plus x square is 2x. Right hand side is 2. Derivative of tan inverse x is 1 upon 1 plus x square, right? Again this 1 plus x square will be multiplied throughout. So equation becomes 1 plus x square whole raised to power 2 into y2 plus 2x into this 1 plus x square into this y1. Right hand side is 2. So prove that x square plus 1 into y2 whole square is y2 plus 2x 1 plus x square into y1, this was y1 is equal to 2. So we say hence proved. That's all. Thank you. Here I want to say you that once again the questions are very important. First of all I collected all these questions on the notebook. You can see here class 12 maths continuity and differentiability. The very first question discuss the continuity of the function. So this was first question, question number 2, question number 3, question number 4, question number 5, question number 6, question number 7, 8, 9. So all the questions I have solved here in front of you, so that the children will get the benefit. Okay, so if you are preparing for your final examinations, class 12 students, then you should at least solve all these questions